All right. Okay, so are you in the right place? This Math 270, Calculus 1. Are you in the right time? Spring 2013. Yes, we all are in the right time, right? Okay, so this is me, Mark Ashbrook. You can call me Mark. I'm okay with that, but anything respectful is fine. Okay, so Mr. Ashbrook is fine. Dr. Ashbrook is fine. I'm not a professor. You can call me doctor if you want. That's fine. Okay, so let's just talk about some nuts and bolts here. Okay, so how do you contact me? Email. Okay, write this down because everything you'll get is I won't hand out any syllabus and paper. It's all online. So I'm in front of my computer all day long. I have the terrible habit of just constantly checking email. Okay, which is good for you. Okay, because I normally just respond right away. Okay. So if you can't, so mark.a is the quick version. If you can't remember, then mark.ashbrook gets you to the same place. Okay, so ASU Blackboard is going to be our home base for the course. You probably all had at least one class that used Blackboard before. That's going to be our home base. We're going to go there in a second, and I'll show you everything there. So on Blackboard, sorry, this is pretty small. The syllabus, you don't have to write this down. Syllabus is there. Written assignments, other course docs, exam results, grades. It's all going to be there. Okay, next thing for getting started is this Wednesday or Thursday, there will be a short to medium length pre-test. You will take that on your own time in the testing center, which is in the basement of this building. Okay, well, when we go to Blackboard, I'll give you more details about that. But just keep that in mind that sometime Wednesday or Thursday, you just got to carve out an hour, hour and a half to do that. Okay, a big component of this course will be graphing software, unfortunately named Graphing Calculator. Okay, this is not a handheld calculator. This is a software. You're all going to have it. And so your number one place to put that would be on your laptop, and then you're going to bring your laptop to class. Okay, we're going to use this extensively. It can do everything that a handheld graphing calculator can do, and a whole lot more, and 100 times better. Okay, so I want to really try to get you to want to use this first. Okay.
Is that included in the package?
No, it's not. It's something I'm going to give you. It's free, and it's something I'm going to give you the code for. Okay. So I haven't gotten the code yet. We're waiting from the company to get the access code, but that will be free. And I think if you really dig in and try to use it, you'll really appreciate it. There will be assignments where you're required to use it. So, and it's very powerful and very good. Okay, so the online text and homework is at my math lab. This will really. Here's the course ID. You can write this down. Ashbrook 04025. I know this is small. You can't really read this. But we will use this very little in the first half. And then we'll use it quite a bit in the second half. So after about a month or 5 weeks last semester, people came, are we really going to use this? Are we really going to, are we really going to use the textbook? Yes, we're going to use the textbook. Second half of the course, okay? But just go ahead and get enrolled now to get the kinks out, okay? All right, so let's go to Blackboard. So the only things you need to really write down here are email address and the course ID for my math lab. So let's go to Blackboard. When you go to Blackboard, here's what you see. So here's, again, I've reprinted the announcement on the announcements page, My Math Lab registration. I even gave you the link and the course ID again there. So if you lose it, it's right there on announcements. The pre-test, Wednesday or Thursday. PSA 21's in the basement. So you're going to enter before 6:30. So you can enter anytime between 10:30 and 6:30. And then exams are collected at 8:15. So there's no time limit, but it will take most of you less than an hour. Okay? No calculator. Make sure you bring your Sun card. And then this is a required element, but in terms of a grade, it'll just earn you some, depending on your performance, it'll earn you some bonus on exam 1. So you want to try, okay? So it's a required element, but you want to do your best to try to earn some bonus on test 1, but it won't hurt you. It can't hurt your grade, okay? Questions about the pretest this Wednesday and Thursday, or Wednesday or Thursday. Okay, and then as soon as I get the information about the graphing calculator software, all that information will be here on announcements on how to download that onto your own computer. Okay, and so then let me just talk through the menus over here. So this is the announcements page. The syllabus is the second one. Okay, and so I wanted to hold off putting it in until our exam dates are finalized. So I've made the request for the exam dates, but as soon as those are finalized, then I'll post the syllabus here. Office hours. So there's my office hours. Mondays 2:30 to 4:30. I'm going to have a Tuesday and a Thursday set of office hours, so this is subject to change. But probably won't be a lot of you coming this week, so we'll get that hammered out in the next day or two. I'm going to have a Tuesday and a Thursday time. And then Owen Davis, everyone, so that's Owen. He's our TA for the course, okay? I will get the information from him exactly where his office is and his office hours. He'll be attending class, and he'll be a great resource for you as well, okay? So probably most of you, to succeed at the level you want to succeed, you're going to be visiting one or the other of us or both, okay? I really highly recommend that, and we'll see why in a second. Okay, so all that information's there. So if you halfway through the semester, you're wondering when my office hours or Owen's office hours are, they're right there on the announcements, okay? And you just show up. You don't have to make an appointment during these scheduled times. You just show up. We're just as nice, if not nicer, in office hours than we are in class. So come to office hours, okay? Don't be afraid. Okay, assignments. This is where you're going to find your homework assignments. Here's the first one. The first is just the bullet points of tasks. Download the printed syllabus. You can't do that yet. I haven't posted it. Enroll in my math lab. Download graphing calculator. You can't do that yet, but just keep in mind these are going to be our initial tasks. Here's actual homework for Wednesday. Okay, I have a kind of a chapter from a book. It's a PDF file. You can read that chapter only through exercise 6 on page 3. Answer exercises 1 through 6. Grade will be based less on correctness, more on presentation, organization, and complete sentences, and illustrations if needed. And that will be pretty much the whole semester when you turn in written homework. half or more will just be your presentation, organization, and coherence, okay, of the assignment. But there definitely will be a significant element of correctness, okay? And then be ready for a short quiz Wednesday on something in the reading, okay?
That's next class or a week?
Wednesday, January 9th. That's 2 days away. Questions on, and this is where, and I'll keep putting assignments at the top. The latest assignment will be at the top of the list, okay? And then the older ones will just get pushed down. So you just come to assignments. Oops. In the assignments, okay. Every day, I will make a video of class. What you will see on the video is what's seen on the screen. And what you hear is my voice, because I'm close enough to the computer. Okay? So it's a reproduction of class. And I'll post every day. And this is going to be a really important element also for you in terms of reviewing and learning the material, because it may make sense in class, but a couple hours later it's going to start to fade because it was the first time you heard it. And then a day later, it could be all gone. All right, that's what the video is for. Owen will be taking attendance every day. Attendance is required, okay? But these videos are going to be a key part. So videos and office hours. If you're not doing as well as you want in the course, and you're not watching the videos and coming to office hours, then that's on you. Okay, that's on you. All right. So this video will be up by noon today of today's class. Quizzes and exams. This is don't need that right now. Okay. But so these are the main things: syllabus, office hours, assignments, class videos. Any questions about Blackboard? Okay. So let's go back. And I want to kind of set the stage. I want to set the stage for what this course is going to be like, because it's going to feel quite a bit different than a lot of you are used to your math courses from the past. Okay, so I want to make this, we're going to take some time right now today to lay this out, and so I want to try to get the expectations clear, okay? So I want to talk about context. I want to talk about math education in the U.S. and in other countries. And then I want to talk about kind of an overview of calculus and how we'll develop it. So first of all, so there was a study, I think this is in, was this in 2000? No, and so first of all, in 1975, they looked at basically the percentage of 24-year-olds that had a natural science or engineering degree. So it's just kind of one indicator of per country, what percent were pursuing science or mathematics degrees. Okay, and so here we see that United States is in second in 1975. So doing pretty good compared to other countries. Okay, fast forward to 2000. Where is the U.S. in 2000? Okay, toward the bottom. Toward the bottom, okay? Taiwan, Finland, Lithuania, South Korea. Doing something, obviously doing something different. Okay, in the math and science classrooms. Inspiring more students to pursue science and engineering degrees. Okay, so something's happening here. There's something's happening in the culture, something's happening in the classroom, and U.S. is not doing well, okay, compared to other countries. Okay, so what is that? So there was so any company that hires you is going to compete with students from other countries, from these other countries. So let's talk more about that. So there, in 2000, there was a video study where they took 100 randomly selected 8th grade classrooms, math classrooms, in Germany, Japan, and the U.S. And so they videoed the classes, and then they made transcripts. They made written transcripts where they stripped anything cultural out of it. So they took out any cues that it would, from what country it would be in. So any indicators of the country that transcript was from were gone. So if you read a transcript, you wouldn't know which country, Germany, Japan, or U.S. And so for these 100 classes, they coded them, or they investigated them all in the same criteria, and they looked at the percentage of the instruction that was considered high, medium, and low. So high quality instruction was considered focusing on meanings, students doing critical thinking, students engaged in problem solving, making connections, okay, coherence of the ideas, all those, that was considered high quality instruction. So how did Germany do? So they were about a third each, about a third high, medium, low. Japan did better. They had more high quality instruction, more medium, and less low. So U.S., what percent in this study, what do you think they found for the percent of high quality instruction in the U.S. classrooms? 15. 20. Less than 10. Yes, less than 10. 0%. Okay, this is what this study found. 0% was high, but instead of high, what was there? Low. So the question is, you've all been in U.S., most of you have been in U.S. classrooms for 10 or 15 years of your life, U.S. math classrooms. What's going on that's considered to be low quality instruction. What do you suppose that is? What's that? Regurgitating information. And so when you say concentrate on math, so what do you mean by that?
We just do it without knowing what we're doing.
Okay, so just like procedures, rote procedures. Okay, what else? Regurgitating, yes. What else?
Teaching us what to think and not how to think.
Okay, yeah. Okay, what to think, not how to think. That's good. Yeah.
Memorization.
Memorization. That's huge. Okay. How many of you had a class like this? The student does some examples, or that's the student. The teacher does some examples of a type of procedure, and then you are given one with different numbers, and now it's your turn to do it. And then the test was just another one with different numbers, and see if you mastered it or not. Agree? So you've all experienced this. That's low quality instruction. Okay? It's not really math at all. It's not really math at all. It's no different than assembling a piece of furniture that you bought at IKEA. That's really the same, or a recipe for baking a cake. There's really no difference. So replicating a procedure that you saw someone else do and explain to you isn't really mathematics at all. Okay? And so that's why we had, and you're all familiar with this, it's by far the greatest proportion of what's going on in the math classrooms in the U.S. Okay? So, calculus, is it just a bunch of complicated procedures? Have you heard of Wolfram Alpha? His best friend, right?
Yes.
Well, so this is called a knowledge search engine. So like, Google's a standard search engine. This is like a knowledge search engine, especially for math and science. You can ask it all kinds of questions. You can't probably read this, but this says, what is the integral of sine x cosine x from 0 to pi over 2? So you can type in a question like that. That's a pretty typical calculus question. And as soon as you hit return, you get a whole page of information about this answer to this. So it gives you a symbolic representation, gives you a final answer, it gives you a graphical representation, and it gives you what's called a Riemann sum. And if you want more, it can give you more. And this is all in the snap of your finger. Okay? What about this graphing calculator software? Okay, so this is saying, some of you might have calculated this before. It says, take the derivative of x to the 3 to the x. Not a simple, straightforward, easy derivative, okay? Again, with a push of a button, it just tells you what the answer is. So there are tools in the world, on the internet, software, that can do these complicated procedures instantly and much more efficiently than we can, and always accurately. Okay, well, not always, but percentage of accuracy would be a lot higher than us doing it by hand and spending all the time to do it. So in the past, this was important. Okay, why? In the past, we learned calculus to get jobs that require doing lots of computing like this. And the faster you were, the better, okay? Because it was more efficient for the company that you worked for. So most people using calculus were given functions and equations. Their job was to do with it what they were told. So this idea of learning these procedures, these algebraic constructions and replicating these examples was important in the past, before we had all this technology. Okay, but what about today? So we said computers can do these procedures far more quickly and accurately than any human. Okay? So I'm not going to pretend that that's true. In fact, so let's use that, okay, rather than try to deny that it's true, okay? So, but computers can't decide what function to analyze or what equation to solve. A human must decide these things in order to tell a computer to do them. So really, users of calculus today are more like managers. Okay. So who knows more about the workings of the restaurant? The waiter or the manager of the restaurant? Manager, right? The manager has to know what the hostess job is, what the waiter's job is, the bartender, the chefs. They have to know the whole running of the restaurant. Have to have a strong understanding of how that all works, that whole system works together. Okay? And so today, that would be what we would expect too. So user calculus must understand what they're doing and be able to explain why they're doing it. So the highest level of understanding is that you could articulate and have a meaningful conversation with somebody else about what's going on in a situation and the mathematics involved in it. Okay, so we don't want to just learn what the computer can already do. We want to learn what's going on behind it and how it all works together. So, reflect honestly. So those of you who had pre-calculus and calculus, when you've worked with symbols and performed computations, to what extent did you understand what it all represented? Okay, so that's not an all or nothing kind of thing. That's a scale, right? Some of you may have been in situations where you didn't really understand any of it, but you knew how to push the symbols around. You know how to write a page of symbols that was what the teacher taught you. Others of you may have had a better understanding. Okay? But be honest, what is your experience? Okay, so this class is about developing an expert knowledge of calculus so that you can figure things out, not just remember what to do. Okay? So if something I present seems as new, seems familiar, if you've seen something before, so pretend it isn't. We're going to kind of start over, okay? Try learning it with understanding, with meaning, okay? So, good math instruction in the U.S. schools is not good by international standards. And don't expect this class to reflect your experience in the prior math classes you've had. So, trying to set the stage here. So, low quality instruction, rote memorization, replicating examples and procedures, doing without thinking to get an answer, and guessing what I want you to say. Okay? What I want you to say is, if I ask a question, something that makes sense. And there's lots of ways to say it. Okay? So these are all examples, and you all came up with them. These are all examples of this, what was called low quality instruction. What is it about? It's about you using your ability to think, okay? And it's possible that in previous courses you haven't been really asked to do that. So this is going to seem unfamiliar and uncomfortable. We want to understand the ideas. Develop insight into the world of quantities and the relationship among them, okay? So calculus at its core is about quantities and how they change. See ideas coming in groups. There's no such thing as an isolated idea. So another typical thing for math classes would be, here's chapter 1, and here's all the problems in chapter 1, so we master those. And then we move on to chapter 2. Here's all the problems there, we master those, right? So it's kind of like they're all separate. But really, this course is going to be a single endeavor for a kind of a final destination that we're trying to get to, okay? So we want to see this course as an endeavor for coherence of all of its ideas, okay? And that final destination is called the fundamental theorem of calculus, okay? And that will take us 3 or 3.5 months to put all the building blocks together to arrive here. And all the ideas that we cover will be important in understanding this completely. Okay? Okay, so when you posed a question or a problem, expect to have to rely on understanding. Bringing together multiple ideas to make connections. Transfer knowledge to new situations. So if you, the real test is not if you can do something you've seen before, but if you can make progress on something you've never seen before, right? Write coherent explanations of your thinking. So being able to communicate your understanding is kind of the highest level of understanding. Okay? And if you have a question, and you're having difficulty, So you may get help or a hint, but we're not going to do it for you. Okay, and so there's a lot of tutoring on campus and in the world where you ask a question, you're stuck on a problem, and they just take the paper from you and they just finish the problem. They say, here, this is how you do it, right? And they just finish the problem. This is not helping you at all. This isn't helping you, okay? What would help you is to be led along in the ideas so that next time you can do it and you understand it. Okay, so a tale of two students. So I check, what is it, ratemyprofessors.com. I check this occasionally. And here's a fun one. Student number 1. He's honestly a terrible teacher. Nice person, but tries to teach the why and forgets about the how. It really kills your grade. I've never had below a 95 in a math class, and now I'm hoping to get an 88. So, the word terrible and horrible are code for the student came in with a certain expectation of what the class would be like. And what was that expectation? A good teacher is what to the student?
Gives everything to them.
Gives everything to them. This is my assumption or my guess. To this student, a good teacher is one that demonstrates and explains complicated procedures really well, and then assigns grades based on the ability to mimic them. Would you guess maybe this is pretty accurate? Mm-hmm. Yep. But let's think this through, okay? If we think this through. So this student wants to spend hours learning procedures that computers can do in a second or a couple seconds, all semester long. They want to work on so that they can get a grade. Further, this kind of instruction we saw is what's put U.S. near to last among other countries. Okay, so am I making my point? Student number 2. For the first 4 weeks of class, I left every day feeling that my brain had been mauled into abstract obscurity. Now I was actually helping my friend from another college with her Calc 1 homework. She was amazed at how much I knew, and even though all of our language was different, I was able to teach her about why each piece works and what it is there for. I have also been helping people at my table from class as well as with homework. It is so satisfying to be having these daily aha moments finally. Okay? It's a Grand Canyon of attitudes here, right? From one to the other. So it's all of us have this student 1 to some degree in us. Okay? You've been in math classes for 10 or 15 years. You've been conditioned that that's what math class is supposed to be like. Okay? Okay? Many of you would see where this person is coming from. Okay? And some of you at the end of the semester may write a similar review. I'm fully aware of that. Okay? Horrible, terrible, abysmal, awful. Okay. But my goal is to win as many of you into this camp as I can. Okay? Because something in terms of internationally what's happening in the U.S., we need to take a different direction because we're failing you as educators, and so we need to take a different direction so we can compete against these other countries. Okay, in terms of grades, so also you'll see on Rate My Professors, oh my, you'll kill your grade, you can't succeed. So here's last semester. I had 69 Calc 1 students stuck it out to the end, and here were the grades. Okay? Totally typical of Math 270 for the last 10 years here at ASU. Okay? So if you work at it, like I said, watching the videos and coming to our office hours to get the extra help you need, you can succeed and get the grade you want in the class. Okay? How am I doing on time? Okay, pretty good. Okay, so in summary, Meaningful learning. It's going to require hard work. You may not be used to this. Okay? It takes patience and perseverance, but the benefits are great. As you saw with that student, so that struggle became success and satisfaction for her. Okay? And for you too. So let's talk about the calculus quickly here. What is it about? There's two fundamental problems that calculus addresses. First of all, you know how much of something there is. There's some quantity. You know the amount of it, and you want to know how fast it's changing. That's the first half. The other half is you know how fast a quantity is changing, and then you want to know how much of it you have, or how much it changed. So this is all calculus falls under one of these two camps. Okay? The first is called differential calculus. The second, integral calculus. Many of you have heard these terms. Derivatives and integrals. Okay? But they're really two sides of the same coin. So differential calculus, really it's about how changes accumulate, which is also what integral calculus is about. And integral calculus is about how things accumulate. They accumulate as the quantity is changing. It accumulates up in bits. So it's really this, they're almost one and the same. They're two sides of one idea. And that one idea is rate of change. Okay? Rate of change. So our goal is to understand rate of change. And then also bringing these together is about the fundamental theorem of calculus. So there was a grad student who she did a study of calculus students' understanding of rate of change. And she did a pre-test before they took the course, assessed and evaluated their understanding of rate of change, and then they took the course, and then she did the same study, or she had a post-evaluation of their understanding of rate of change after the Calc 1 course. Unbelievably, was their understanding better or worse of rate of change at the end? It was worse, okay? It was worse. And why was it worse? What would you suppose? What happened in those 3 months of the course that made their understanding of rate of change worse than it was before, when that's what calculus is about, rate of change? What's that?
Expectations of the class.
Expectations of the class?
Maybe they were used to some kind of knowledge of rate of change. It wasn't what they expected.
Okay.
They thought that they could just perform one certain function on every problem and get the problem right, but they actually need to apply it in different ways.
Okay. Yeah, it goes back to this quality of instruction issue that we talked about. If all semester long they just did procedures relative to the calculus, then it didn't help their understanding of rate of change. Okay. So let's get started on a little bit of math. So let's do a little intro on quantities. So here's the situation. Instructions on a drink mix container say that 16 tablespoons of powder should be mixed with 60 ounces of water. Okay? First question is, how can we model the quantities with an illustration? Okay, and so I'm not talking about drawing a canister of country time or a pitcher under the faucet. That's not what I'm talking about. So in terms of how can we make an illustration that represents these quantities of the amount of powder and the number of ounces of water? Yeah. Yeah, he said make a graph, right? So, and exactly, a graph is exactly what that does. A graph represents the amounts of quantities. So this may be a graph that you're not familiar with, and it's what we're going to call bars, okay? And so with the bars, the length of the bar represents the value of the quantity. So here's kind of a typical bar illustration. So I've got 2 bars here, and we've got the situation where 16 tablespoons of powder corresponds to 60 ounces of water. So how can we use this illustration to represent that situation? Start nice and easy here. Hopefully this is easy. Yeah.
Yeah, the lower bar is the reach is the amount of the powder versus the water.
Okay, so he wants the lower bar to be the amount of powder. And what about the upper bar? How much water? Exactly. Okay, so we can label it. So we said this is the
water.
yeah, the tablespoons volume of water. And how much water is there? 60 ounces. Okay, and then this one was?
Tablespoon of powder.
Amount of powder. How much?
16 tablespoons.
Okay. All right, so here's a question. How many ounces of water should be mixed with, I'm going to change this, 4 tablespoons of the mix to achieve the right taste? Okay, so this is not about cranking out an answer. What this is about is using the illustration to represent what's going on here. So that's what I want you to do. Rather than, so no cross multiplication. Allowed. What's cross multiplication? A over B equals C over D. Therefore, what? AD equals BC. So this has a lot of procedural feel to it, okay? And we don't want that. So rather than just going for the answer, it's more about how do we represent the situation with the illustration. So try that, and if you want to show and compare with the person next to you, go for it. So just take a minute. We've got this situation. How many ounces of water would be mixed with 4 tablespoons of mix to get the right taste? Use the bars to illustrate the situation. Compare with the person next to you.
Well, I just did it.
Oh, each by one.
I'm going to call on someone randomly in about a minute, so have something to say. Have something to say. Okay, where's Stanley? Stanley Lubansky. Right here in the front. Any ideas?
Well, I split up, since you're asking for 4 tablespoons.
Okay.
So that's a fourth of the amount of powder.
Okay.
So I broke up that bottom bar into 4 equal bits.
All right, let's start with that. So he said, and so this first bit represents what?
That'd be 4 tablespoons.
4 tablespoons right here. Agree with that?
Yeah.
Okay. Want to keep going?
Yeah, and then for the volume of water, I just also split that up into 4 equal parts.
Okay. So because we're taking, so basically we're splitting a 16 up into 4, then he's saying split the water up into 4. So that 4 tablespoons will correspond to,
15.
and so now step back and think, where did you get 15? So what operation is that? Yeah, you're just dividing 60 by 4, right? So this is 15 ounces. Do you see that the difference between that and 16 over 60 equals 4 over x? Do you see the difference between doing a procedure like this? Okay, it's really just you're reasoning about the quantities, and that's what we want to do all the time. So we want to reason about the quantities. Does anyone approach it a different way? There could be a different way to think about this or use the diagram.
Well, something I've thought of, those lengths, your proportions are always going to be equal to those
Okay.
lengths, right?
Yeah.
So your 4 could be equal to that length, and your 15 could be equal. Does that make sense? So like your 4 and 15
Yep.
could be the same length as your 4, your 16, and your 60, because it's the same proportions. Like the top line is always going to be that much greater than the bottom.
Okay. Right. Okay, so what he's seeing is that the relative size of this piece right here, is that what you're saying, right?
Yeah.
The relative size of that to that is exactly the same as the relative size of the original 2 bars I gave you. Yeah, that's a good observation. Okay, the relative size of the original bars is the same as the relative size of 1/4 of each of them. Okay. So that was an easy warm-up. Same situation. 16 tablespoons mixed with 60 ounces of water. Little bit more challenging. Use the bars to solve and illustrate how much powder would be required for 200 ounces of water. Okay? Now, you're not allowed to extend the bars. You got to use these bars to illustrate that situation. Again, no cross-multiplying. This is slightly more challenging. See what you come up with, okay? No cross-multiplying. You've got something to talk about? Talk about it with the person next to you. See what you came up with. It's different. You got to do something different on this one.
I just counted those things. 24, so
bars represent. So use the bars to represent these quantities. What do those bars represent?
I guess, yeah.
Good.
This part is
Would be what?
So we just divide
That bar would be what? Okay. Okay. So start by showing that.
Oh, I think 60. Small one.
So what do these bars represent now? Can the top bar be 60 ounces of water again?
No.
Why not?
Because we're
Right.
too much.
It's going to be.
Oh, just use the same length of bar.
You got to do something different on this one. Okay, good. All right, so where do you go from there? So the top, you don't want 60 ounces because what's in question here is 200 ounces of water.
And then it's also how many tablespoons. Basically 40 tablespoons
Good.
of powder, right? And is it 16 tablespoons or 6 ounces?
So then, some people don't even have bars written drawn on their paper. We're going to illustrate it with the bars. We got to draw the bars. Some people don't even have paper on their desk or a pen in their hand.
Or you could divide by full portion. The top are 200 pieces. And then each.
So what's the top bar represent? And what's the bottom bar represent? 16 tablespoons is the bottom one. Is that right?
No.
We don't know.
That's so the bottom bar now, the length of the bottom bar is what? It's our unknown, right? That's what we're trying to find, right? Okay, so how about Autumn Coleman? Is Autumn here? Oh, okay. It was not by design. So did you start this way?
Yeah.
Okay. Where did you go from there? So now there's at least 3 different ways to approach this. Okay. And any.
Well, I first tried to find multiples of 60 and 200 so I could split up the bar, but that's kind of not really a good idea.
Okay. Well, so you're.
Three portions.
So. I think that's a good idea. In fact.
Oh.
So you're looking at particularly how much water?
Well, I was looking at 200 ounces and I divided by 3 because if you divide 200 by 60, you get 180. I mean, 3. Sorry. Ugh.
Okay, so you're thinking of like packets of 60 ounces.
Yeah.
How many packets of 60 ounces would go into 200? That's what I'm hearing you say. So let's just draw the first one. Where would it be? Would 60 ounces be here?
Now like a third of it.
Yeah, somewhere around here. Okay. So that'd be 60. And then if we want to take another 60, what would that be?
Another third. Basically. 120.
120. Okay, and then?
And then 180.
Okay, so I didn't do a good job here. Proportionally. Try again. I'll just start over. Okay. So maybe 60 is here. $120. And then does the next amount of 60 make it up to 200? What does it make it to? 180. And then how much?
20 ounces.
Okay, 20 more. So we're representing the 200 ounces in amounts of 60. And how many amounts of 60 are in that 200? So count with me.
1, 2, 3.
How much of an amount of 60 is that? 1/3, right? So how many 60s? So there are 3 1/3. 60s in 200. And what does somebody know? So, where's Andrew? Locus or Laux? Laux. Okay. So, 60 ounces of water corresponds to what?
16 ounces of water.
So,
Tablespoons, sorry.
okay, and so would the 16 go here?
No.
Here?
A little farther.
Right. So our 60 ounces corresponds to 16 tablespoons of water. And now, how can we use the way that we illustrated the water now to?
So then you'd also have 3 1/3 16s.
Yeah, 3 1/3 16 tablespoons to get the right taste, right? So we're going to have, there's 2, there's 3, and then 1/3 of 16. Or
48.
3 1/3 16s. What operation is that? 3 1/3 16s. What do you do? Multiply. What do you got? Tell me again. 53.3. Do you see how that reasoning, again, in this problem, world's different than setting up the ratios and cross-multiplying and being done and not really thinking about it. Okay? But it's this kind of reasoning about quantities that's really important. So we saw in the previous one, well, in both of them. So what are the operations in play here? The operations in play are multiplication and division. Are the main operations in play. And these are actually the main operations that are the building blocks for calculus. And so in this next couple of days, we're going to be working with these bar diagrams and really kind of pulling apart, dismantling multiplication and division, so we really understand what those operations are achieving. Okay, so we're going to be looking at foundations of multiplication and division and how they affect quantities. Remember your homework again is the assignments. It's all laid out. 1, 2, and 3 here for Wednesday. Okay? See you then.
Mark.